It's a big challenge. It's an exciting challenge. It's got huge potential. Greener air travel has been on the agenda for a while, but what we're at is a point in time where it's becoming a reality.
A global industrial revolution is underway.
Yes, we have a technological challenge for our environment, for the well-being of the population of the planet, for civilization.
Driven by passionate, dedicated individuals intent on shaping a new world.
I do it because I look at my kids, and I honestly, I'm convinced that this is the way.
A cleaner world.
There is a way forward other than burning fossil fuels out of our funnels.
A greener world.
This wind farm is producing more hours of power into the grid than all wind farms in the UK and probably in the world.
What we've done in the past is not going to solve these challenges. We need to find new ways, and I think the only way to do that is to bravely step forward and implement technology.
Together, they are pushing engineering to its limits to create extraordinary machines that can protect our planet for the future.
If you want to go somewhere, the airlines tell you what airport they take off from, what airport they land at, and when they want to fly, and you have to meet your schedule to that.
Is it sustainable environmentally?
The European Union predicted in 2015 that global CO2 emissions coming from aviation go from about 2% to, by 2050, being something closer to 20%.
We cannot be in a position that this industry, the aviation industry, takes such a large chunk of the total carbon footprint and energy use footprint.
Steve Wright spent over 25 years working on some of the largest aeronautical projects in the history of aviation. Now helping to teach the next generation of aerospace engineers, he understands better than most the challenges faced by those seeking to move away from fossil fuels.
Hydrocarbon fuel has been God's gift to the aviation engineer like me for the last 150 years. And let's explain that. Let's put a number on it. Fuel as we know it, it contains about 40 megajoules per kilogram. Good old nature has stuff called lard, food of champions, 37 megajoules per kilo. Dynamite, for example, only 6 megajoules per kilogram. It's just very good at letting out that energy very, very quickly. But now let's talk about our batteries. A battery, current state of the art, probably only about 1.5 megajoules per kilogram. Admittedly, electric engines are probably about twice as efficient as the internal combustion engine, but it's still only a fraction of what we can achieve with petrol.
When Norway announced that within just 20 years, all of its short-haul flights must be on electric aircraft, it sent shockwaves around the aviation world. But a new breed of homegrown aviators have already risen to the challenge, intent on creating a green revolution that only a handful of years ago most would have deemed unthinkable.
Well, this story really starts in the garage, you know, moving back to my parents' place, starting to build and design parts for the aeroplane.
Thomas Brodershift isn't your typical aircraft designer. He actually intended to have a career working in industrial product design, but a decision he made when looking for a case study as part of his degree would change his life.
I came to thinking that wouldn't it be interesting to use some of the industrial design processes to see if we could create aircraft that are different. So I basically used the exact process that you would normally see if you're doing a bicycle or a coffee mug or whatever, because the process of designing something is more or less the same. You have to analyze the way that people use the products, the way that they interact with the product.
And what he realized was that people were quite dramatically changing the way they wanted to travel.
Living in Norway, we're already up to 30–40% electric cars. So for me, the first time I drove an electric car, I felt like this is definitely the future, right? It's silent, it's clean. Once you go back to the combustion engine, after that, you're shifting gears and you're listening to the explosions inside the engine, and you kind of feel the heat and everything, and you think, wow, this is not the way to go.
Norway's rugged terrain has always presented challenges to the traveler. But Thomas became gripped by the idea that electric aviation just might be able to turn one aspect of this dramatic landscape to his advantage: water. And in particular, Norway's 450,000 lakes and fjords.
The main challenge, which I find fascinating, is trying to make a flying boat that can fly as efficiently as a land plane. And the whole reason why this is possible is the electric technology. The whole reason why we can suddenly do this is because we don't have to bring a big, heavy combustion engine with the propeller. We can start to distribute the power with a light electric motor, and suddenly there are so many opportunities that the last designers the last 100 years have not had. You can suddenly make aircraft that are completely different.
Since those early years, Thomas has been joined by a small group of highly talented, like-minded individuals. And today we'll see the culmination of over a decade's hard work, dedication, and belief as the team prepare for the very first test flight of what they hope will form the blueprint for a new generation of seaplanes. But before they can even think about taking to the water, they need to establish whether the plane can fly at all.
2 or 3 people designing a plane here, so none of which have done it before, ever. Everything in this plane's been made by hand, by us. And of course we've done everything we can to verify every single detail. But at some point, somebody has to take that plane off the ground. And you want the person that can handle the worst case scenarios, who can keep their cool, and you need a professional. Otherwise we might end up crashing the plane if something is off. And the chances that something small is off is quite high with a concept like this.
And the person chosen to take the controls is Eskil Amdal, Norway's most experienced test pilot. A man who has flown everything from World War II fighters to the latest F-35 Lightning.
Because everything is theoretical up to the point where this aircraft leaves the ground. Everything is just on paper. So you have an aerodynamicist saying, yeah, it's going to be stable, but you don't know until you fly it, right? So it's this extremely nervous time, and I really, it's almost a blur for me, everything up to the test flight.
Okay. Good. Good luck.
Herlig! Fantastisk.
Seaplanes aren't new. People have been doing them since the dawn of aviation, of course. But we're traveling from Oslo to Hamburg, for instance, and we want to land on the river next to the city. This is not allowed today because of the noise that the combustion engine and the high rev propeller that these seaplanes need to get out of the water produces. It's something that people have been pushing away from cities, basically. So with the electric technology, of course, this can completely be reduced by a huge amount of decibels, maybe 50% lower, and you're down to like a normal boat or something. At that point, you can't really argue that these airplanes shouldn't come close to the cities anymore. So that's the big change, you could say, that will come with this, is silent green products should be able to come closer to the cities. It's really strange, but it's first kind of relief, but it's almost like a dream, and it became very emotional as well. And especially when Eskil also, I remember he stepped out of the aircraft, and I gave him a big hug and started crying. I never cry, but I cried. In 10 minutes, you get the answers for 7-8 years of work. Right? The test pilot has this amazing sensoric equipment, right? The body, and he can immediately feel everything that works, everything that's wrong. I think in any prototype where there's a novel plane, where there's a geometry that's never been tested before, it's extremely hard to hit the mark without getting a list in the end of things you have to change.
Thomas and his team at Equator are now building up to sea trials, while at the same time using the test data to develop a new 4-seater version. With a flying time of 2 hours and a 500-kilometer range, which he hopes will go into production within just 2 years. But that's only half the story.
So the big question is, who's going to take responsibility for investing in and changing the airport infrastructure and the harbour infrastructure to be available so that people can charge their electric planes? We are there with a product ready. We need it to happen in parallel. Otherwise, it's completely unsustainable in a way, the whole project.
One of the things that we need is universal systems that we can all just walk up to and plug into. What are we talking about? We're talking about what kind of voltage we use, what sort of power we can deliver and how long it'll take. And in the simplest case, it's what shape is the connector that plugs into my aeroplane today.
Aware of just such issues, Sweden and Norway have jointly set up Green Flyway, a unique international test arena for future aviation. Covering a vast area and including 2 international airports, it's a place where designers, engineers, and aerospace companies can develop ideas, test theories, push boundaries. The scheme represents a bold statement of intent and is attracting aviation pioneers from around the world.
I'm representing Pure Flight from, it's a company from Czech, and we have developed this airplane. It's an all-electric airplane with a 35 kilowatt-hour battery and can fly around 3 hours plus with a lot of reserve.
Winter conditions are just one of the many challenges electric aviation must be able to cope with to satisfy not only regulators, but also future operators. Green Flyway is also enabling airports to understand what infrastructure they will need and how best to supply it. But if electric aviation is to make an impact in the mass market, there will need to be a larger solution. Inspired by Norway's bold directives, Anders Forland and his partner Clara Andresen believe they have the answer.
This is the heart, ES-19. It's a 19-seater all-electric aircraft with a range of 400 kilometers. And our goal is that this aircraft will be certified for commercial service by 2026.
It's a huge moment for this new startup, in front of some of the most influential people in the business, not to mention members of the Swedish royal family. they are about to share their vision with the
When I
world.
realized this, this is not a research project. This is something that we need to commercialize now.
They may not yet have a plane, but they do now have a way of powering it. Or, to be more precise, they almost do.
Yeah, we had a little bit of a hiccup, I guess, when we were doing this thing. We think we've isolated the problem, and it really goes to show that you need to iterate on the design. So now it should be fixed, and we should be able to run it.
If this company is to capitalize on the interest they have generated, it's imperative that a series of vital engine tests are successful. But in an industry not known for doing anything quickly, what they have achieved so far is nothing short of remarkable.
Our journey started in early 2018. At that time, I was a researcher at the university here in Gothenburg, and I just come back from a researcher exchange at MIT, and I was really convinced that electrification is the future. And if we wanted to do this, we had to start creating a company now, because the technology is already here.
Anders' passion was shared by his fiancée Clara, and together they applied for seed funding from Y Combinator, an American investment program that has helped launch many companies that have gone on to become household names.
I quit my job. Clara quit her job.
It was mixed feelings in the beginning because I had a really good job and like a secure income and everything. And but like we understood, both of us, that this was going to take so much time and energy. So either we do this together, or I mean, we can't really be together.
You know, at this point where you're like two people and you say you want to build an aerospace company, it's like you're taking on a huge challenge, and you have to be, I guess, a little bit crazy. But it's, I guess, if you're crazy enough to think you can do it, then you're halfway there.
By the summer of 2020, they'd secured hangar space, offices, a small dedicated team of 12, and a concept that was beginning to migrate from the drawing board into something more physical.
Let me show you around a little bit. You need to take a cue from the startups of the software industry, where you have a small team that's talented, that has engineers that are working a little bit harder, that are using all the latest tools. And if you just get that sort of mixture right, you can take on the world. And here's Nigel. Hey, Nigel.
Hello.
Yeah. His resume is almost like a modern history of aviation.
Nigel Pippard's official title is Chief Technical Officer. But amongst a team for some of whom the ES-19 will be their first aircraft, he's affectionately known as Gandalf.
We found some of the best people in aerospace that I'm amazed every day to be able to come to work with these people. To discuss as well, should we take a step back, go back to the drawing board, or is there a virtue in just pushing ahead and seeing where this iteration takes us? Then we have Benjamin, and Benjamin he's something out of this world. He basically created, so there's this thing called electronic motor control, and it's how you program the electronics so that you can make motors spin. And he basically created a global standard for this out of his basement. His software has made its way to, I think around 200,000 different electric machines, everything from, electric skateboards and motorcycles, and even he's working on one project to build an electric heart, which is really, it's funny because of the name of our company.
The thing I love about this whole electric revolution, it's actually a piece of physics that's been around for 150 years. Visualize a series of electromagnets in a ring and a bar inside it. So we switch each electromagnet on in turn, and causing a big piece of metal to jump between different positions. We want to switch those magnets in and out really, really quickly, but we need to switch them in smoothly. We need a gentle handover between them. Otherwise, the thing will lurch around and it'll buzz and it'll shake and rattle. So what's changed that's made this all possible? The extra magic that made it all possible was cheap computers in the 1980s. The moving parts in this thing is simply a lump of iron in the middle. But what does it give us? It gives us an incredible force, something that a conventional electric motor can't.
And the fact that we as a small startup can develop something with the performance of the jet engine, an efficiency that's about 3 times better, and do that in 5 months, I mean, it's like too good to be true for an engineer. It's like really, really exciting.
So this is the equivalent for the 21st century of the mechanical engineer in the garage tuning his internal combustion engine to get that perfect sweet note and the best performance out of his engine. But these guys today, they're using software.
The entire electronics and software for the entire rig here is something that we have, that I have written mostly by myself. I think for the certification, to make sure that everything is safe, you almost need to be able to build a system like this in order to understand it well enough.
And that certification process is also behind what to some might seem the rather unusual choice of having 19 passenger seats. In reality, it's just one of many examples of the pragmatic approach this young company is taking to get a large electric passenger plane into the skies as safely and quickly as possible.
This year, the first electric aircraft was certified. So that was the Pipistrel Velis Electro is what it's called right now. It's 2-seater aircraft, and that's a certification basis.
Certification signifies the airworthiness of a particular category of aircraft and is needed for serial production and commercial operation.
That extends up to 19 passengers. So we can use that framework that they've used to certify that aircraft to certify ours. And that's why we can have a very aggressive timeline on when we want this aircraft to be in the air. If we go to 20 seats and above, it becomes the same certification basis as a jumbo jet, essentially.
So what they're doing here is sensible. It's an incremental step. They've seen an opportunity that they don't need to completely reinvent the aircraft. They only need to address the propulsion system.
But if this vision for a brave new world is to become a reality, Anders and his team need to prove that their motors and batteries are up to the task. As a simple way of recreating how a motor would drain the batteries in real life, they've come up with the ingenious idea of using an array of halogen light bulbs.
And the thing that happens is that when you're just starting, we draw the most power because you have to take off and climb. And then eventually we get to cruise when we don't climb anymore, and then the power is going to drop. You can probably hopefully see that the lights get dimmer now, and that is because we need less power to just keep the same altitude and keep going. As far as we can tell, these batteries are going to last for a very long time, and that makes me really positive to this whole thing.
Theory is one thing, but will Benjamin's latest software work in practice?
We connected the battery module to the motor controller now, which can provide probably 10 times more power than we could before. Now we have the full voltage of all of those modules in series through the fuse to the power switch. And now we'll go and switch it on. Don't broadcast it if this thing catches fire now. Spinning it up at much lower power, but with the full voltage, and see how that goes. Seems to run fine so far. So I'm gonna push it a bit more. I'm gonna increase the limits a bit.
It's difficult to overstate how important this test is. The motor represents the very core of the entire project.
That didn't sound so good. If the fuse does blow, then we're probably going to have a problem, because then we get a huge inductive spike, but yeah, let's go for a risk.
Don't do something stupid. Yeah,
yeah, I'm getting too confident here.
Yeah.
But let's set it to 70 amps, then we're probably safe for the fuse at least. Okay, so should we go? Yeah, that's a bit more wind.
The ES-19 is now one step closer to reality.
We have to increase that 10 times again.
Yeah, but that's the next step.
It's not the act of time passing that makes a new technology grow. It's the work of engineers that are working, and pushing the technology towards their edge. One of the most rewarding things of what we're doing is that you find out that there's an extra gear. There's one. You might think that you were doing your best or working as hard as you can, but there is actually an extra gear that you can find where you can turbocharge what you're doing and achieve much more than you think that you ever could.
But what if you don't want to wait a few years for a new electric aircraft? When de Havilland's DHC-2 Beaver first flew in the summer of 1947, few could have imagined that over 70 years later, the same airframe would herald a new dawn in the history of aviation.
To take that aircraft that you love, that fits your needs, that does what you need it to do except for that engine, convert it to electric, can actually make sense. And so we're enabling the operators, no matter what their path is and their growth is, to go electric.
Which is exactly what Harbour Air in Vancouver chose to do with this iconic float plane. But it required more than just a straightforward swap.
When you go from a large, heavy radial engine, for example, on the E-Beaver, and you go to a small, lightweight electric motor, in order to maintain the center of gravity of the aircraft, we had to put the motor more up front. So we basically elongated the nose of the Beaver, making it more aerodynamic.
In December 2019, its 750 horsepower electric motor was about to be put to the test. With the attention of the world's press fixed upon it, it would attempt to become the first full electric commercial aircraft in history.
Even without the electric aspect of it, the aircraft became more aerodynamically efficient. So we could, with less power, fly the same aircraft, which was a tremendous lesson in itself.
Following on from their success with the 5-seater de Havilland, Magni X turned their attention to the much larger 9-seater Cessna Caravan, a rugged workhorse used the world over.
When you're doing something that wasn't intended to be done, then there will be both losses and gains. If we take the Cessna Caravan, for example, on a regular engine or with its internal combustion engine, you'll be able to fly up to 1,000 miles in range, 1,000 miles, which is phenomenal. Now, no one really flies 1,000 miles in a Caravan. There's no restroom, it's unpressurized, etc. But it can fly up to 1,000 miles. On batteries, the electric version can only fly about 100 to 150 miles with today's batteries. The flip side is your costs have gone down significantly. For an hour-and-a-half flight, you'll spend $24 on electricity, $24. Compare that to the same internal combustion engine Caravan for the same 1.5 hours. You'll spend $404 on fuel. $404 compared to $24, that's fuel alone.
The potential niche appeal of such retrofits is just part of the picture. In reality, they are serving a much larger purpose.
So if you were to go a year ago or 2 years ago to a battery company and say, hey, why don't you guys develop a power source, a source of electricity for an electric plane? The answer would have been, what electric plane? Had you then gone to airplane manufacturers and said, hey, why don't you guys develop an electric aircraft? The answer would have been, with what propulsion system? Now there's a propulsion system that is powerful enough, lightweight enough, reliable enough, redundant enough, etc., to power an aircraft. Now design these aircraft for it.
Which is exactly what a physicist based in Israel decided to do. But first, he needed a company to make it. So he started his own.
A lot of people, when we started this endeavor, a lot of people asked us, well, you intend to be the Tesla of the skies? And we said, no, this is the wrong comparison. We're trying to build the Model T of aviation. We're trying to build that aircraft that allows regular people with regular income to use the skies for regular transport. That's very different. That's not your odd vacation business trip or, flight to visit auntie someone. This is your day-to-day commute reinvented.
Having a dream was one thing, but the big question was, would anyone else want to share it?
So you need your operators to really be in a position that it makes economic sense for them before you can say, okay, don't worry about it, I'm going to build a car-like aircraft and everybody's going to buy it and it's going to be fine. The it's going to be fine part is not really part of the aviation industry on a day-to-day basis.
The sector they wanted to target were the operators of small regional aircraft. After much consultation, it turned out that 9 was the magic number. But in order to break into the market, they were going to have to come up with something pretty special.
So the Aviation Alice is a 9-seater aircraft, 9+2, meaning it has room for 2 pilots or crew members.
With a range of over 440 nautical miles and a cruising speed of 220 knots, the Aviation Alice offered the promise of low operating costs made possible by its electric motors. It was enough to secure a substantial prospective order, which meant that the pressure was now well and truly on.
One of the things we did, actually the first investment of this company, was to buy an really obscenely large supercomputer and use it for simulation. I think at the end you can simulate as much as you want. At the end you need to actually build it and see how it works. So how many planes we've built before Aviation Alice? The simple answer is 0. As a company and as a person, we've never built a plane. And I think it's, I don't want to call it refreshing because it's obviously there are some advantages to coming in to a project with the enthusiasm and the kind of clean slate design and thinking. But in all honesty, this is a very, very humbling industry and there's plenty to learn.
Omer and his team reached out to over 100 experienced subcontractors in more than 20 countries.
We had to go through the, jump through the hoops and convince them that this is worth their effort and this is worth their risk sharing so that they can be on board this aircraft. Some of them are huge names that everybody knows in the industry. Some of them are smaller players. But yeah, the joke in the company goes, how do you build a plane with 50 people? And the answer is, well, together. You need a lot of people working with a lot of other people and a lot of kind of expert groups. So there is a design, but it doesn't mean we're the best people to, for example, build the tooling and actually execute on building that wing.
One company that took no convincing was Magni X.
When you can design something from scratch and have higher redundancy of propulsion systems and put them in really efficient places because they're suddenly small and lightweight, you can do some amazing things. The Aviation Alice has 3 motors, 2 of them on the wingtips. There's a lot of aspects to that increase the efficiency of the aircraft. For example, sometimes you see these really cool movies of aircraft flying through the air and they have these really nice smoke swirls on the tips of the wings. It's really cool visually, it's really bad for the aircraft because this creates tremendous drag on the aircraft and it's basically pulling the aircraft back, which means you have to put more power in order to move forward. Imagine if you could put propellers on the wingtips that rotate exactly the opposite to those swirls you get to see, basically eliminating them. Suddenly the aircraft can fly smoothly through the air and have less drag, which means you need less power to fly. When you have propellers at the tips of the aircraft, you can actually use them to help you control the aircraft. So imagine today what's known as crabbing. When you're coming into land and there's a strong side wind, because the engine is either on 2 points on the wings close to the body or in the center on the nose, then what you do is you come flying into the airport almost at an, or not almost, at an angle, sometimes a very extreme angle. Again, you can see this if you look at kind of side wing landing videos. You can see the aircraft flying on a side into the runway and you think, oh my God, how is this thing gonna land? And then at the very last minute, they straighten out and land. Imagine if you could independently control the 2 wingtip motors. You could, as a pilot, fly nose straight into the runway exactly as you would want to without trying to manipulate the aircraft. And so it allows you to really do things, again, that up until now have simply been physically impossible.
By 2019, they were turning heads at the Paris Air Show. But although it was potentially capable of flight, this plane was scheduled for intensive ground testing in America.
Yeah, it's an aircraft, it could fly, but what is it good for? There are a lot of planes out there that are flying their, maiden flight, and that's it. It's a proof of concept. Even if they achieve something amazing, like they break a record or they fly very far, very high, that's great, but that's not what we're trying to achieve. This is a company that's building a product. This product needs to be safe, it needs to be certifiable, and it needs to be manufactured in scale for a price that makes sense for the industry. And that pushes you, and in some cases, pushing hard gets you to a place that's risky.
At the start of 2020, just a few weeks after the aircraft had made a sensational debut at Paris, the Aviation Alice was hitting the headlines again. During ground testing, the aircraft was damaged by an electrical fire caused by batteries. Ironically, the fire was caused by a fault with ground-based equipment, but inevitably, it raised questions about the safety of battery-powered flight.
If you're worrying about batteries, let me give you this thought. Let me put your mind at rest by suggesting, how would you have felt if somebody had turned up with a jet engine as a brand new thing? Imagine what we'd be up against if we tried to persuade somebody to get on board a vehicle carrying 100 tons of kerosene, and then someone explains to you that they're going to set fire to it just over there on the wing next to where you're sitting. You might be alarmed by having a fire. All I'm concerned about is, can we contain that fire when it happens? Because the fire, it's a sign that we're pushing the technologies, we're discovering the boundaries of where we can go. One way I always put it is, we as engineers have suffered, so you, the customer, doesn't have to.
As one of my good friends in this industry told me, Omer, you're building an aircraft, you have all your people safe, 3 wheels on the ground, and the aircraft is still standing. That was a good day. The testing campaigns that we're taking are part of the development process that you cannot avoid. If you're avoiding it, you're not going to have a proper product at the end.
One design change that came about as a result of the fire was another layer of safety. The battery system was separated into 16 fireproof compartments, each with enough energy to safely power the aircraft on its own.
If, God forbid, it happens, and obviously you need to prevent it, it's still safe for the mission and for the passengers. Maybe you won't get where you wanted to go, but the idea of aviation is not just prevent failure. It's, if something happens, fail safe. And that's where we're going, and I think right now on the battery front, that's where we are.
With flight testing about to begin and an estimated price tag of $8 million, the Aviation Alice has already secured high demand for potential orders, and the company are already planning an ambitious production run.
I think hundreds per year that will add up to quite a few thousands within a decade would be a realistic approach.
Although the electric aviation industry may be in its infancy, there's general consensus that as battery technology improves, its growth will be rapid.
Anecdotally, when we started flying the eBeaver, we had batteries that were about 145 watt-hours per kilogram. Today, we're already seeing batteries at 400 watt-hours per kilogram. This is less than 12 months later.
On the one hand, the chemists are going away and discovering new chemicals that allow us to cram more energy into the very box itself. Then there's systems engineers like me who are finding ways to operate those batteries more efficiently, to nurture them and coddle them, as it were. And in the middle, the electrical engineers can arrange these cells in different configurations as well. Do we put them front to back? Do we put them side by side? All these options are up for grabs in this brave new world.
Britain's Cranfield Airport describes itself as an ordinary licensed aerodrome which carries out unusual research. Although today this is just a ground test, this same plane, operated by Zero Avia, was the world's first commercial-grade aircraft to complete a flight powered by a hydrogen fuel cell. A hydrogen fuel cell is a device which uses hydrogen gas together with oxygen from the atmosphere and converts their chemical energy into electrical energy, which can be used to drive an electric motor. When Zero Avia made their groundbreaking flight in September 2020, it was hailed as a landmark moment.
In the conversion process, so taking the chemical energy of the hydrogen into usable electric energy on the aircraft, you combine hydrogen, H2, with oxygen from the air, which is O2, and bringing that together creates H2O, water. And that is really the only waste product that you have on a hydrogen electric system like ours. And that water you can discharge during flight, and it does not create harmful emissions or any climate effects.
Their first flight was only around 15 minutes. Now they're testing the systems in preparation for a flight that will last over 2 hours and cover 250 miles.
Now, of course, as this gets rolled out commercially, you will start needing to have stationary infrastructure. And that is something that we are working on as well, to make sure that at an airport you can produce hydrogen from renewable electricity, so zero emissions. You can store it on site, and you can fuel it into any aircraft that you will want to fuel. What you see here is on the left of the container, you see water, just regular water. And that water gets used in the electrolyzers. The electrolyzers take that water and split it with electricity. And that electricity can be green, it can be zero emissions, it can come from solar or from wind. And that's really how you produce green hydrogen. Storing the hydrogen is not enough, you need to actually make it usable. And making it usable happens with a really standard fueling system. So you have this nozzle here that you plug into the aircraft, and then you press the start button on our system. The system fuels the aircraft, and once it's full, it is ready to go and fly 200, 300 miles.
This retrofitted Piper M-class six-seater is destined to only ever be a flying laboratory. For commercial operations to be a success, the team here at Zero Avia will have to accommodate something considerably larger.
In fact, hydrogen is actually 3 times as energy dense as jet fuel per kilogram of fuel, which is really exciting.
As an example of why it's so important, the maximum takeoff weight of an Airbus A380 is 565 tons. If its tanks are full, fuel will account for 254 of those tons, 45% of the total weight. Reduce that weight, and you reduce the energy required to fly the plane.
Because that's ultimately what really matters in an aircraft. As you move up the scale of aircraft, at some point it simply becomes infeasible to fly with batteries. And at that point, you have to switch to hydrogen. So our vision is actually developing a system that is scalable across the entire range of aircraft. We have first commercial use cases actually as early as 2023, But ultimately, the system can scale from something like a 6-seat aircraft to a narrow-body aircraft like an Airbus A320, which is something we'd be looking at in the 2030s. There's always a strong sense of purpose. I think you can feel that across the entire team, that everybody's really dedicated in actually making sustainable air transport. 50% of the world's air travel is less than 500 nautical miles. That's exactly the kind of market that we are targeting with our hydrogen electric powertrain. And that is why we're so excited about its potential, because you can eradicate all carbon emissions from 50% of all flights today.
It seems like a silly little toy, but in fact, it contains all the systems that are shaping a whole new sphere of electric aviation.
At Marina Bay, Singapore, a team from the German company Volocopter are making last-minute preparations. They hope that this aircraft will be able to make a landmark flight that could shape the future of urban air mobility. The origins of this remarkable story can be traced back to 2011, when Alexander Zozel and his friend, software designer Stefan Wolf, unwittingly became internet sensations.
Well, it all began when I saw these small little multicopters, I mean the remote-controlled ones. You know, I'm kind of a technical guy, so I thought, what would it take to scale it up such that a human can fly with it?
It was the first manned flight of a vertical takeoff aircraft powered by electric motors. But it was their choice of undercarriage that also captured people's imagination.
We were thinking about a solution that was very lightweight. And it turned out that these yoga balls are approved for like 400 kilograms or so. Even today, if you ask someone, Volocopter, what's that? Ah, we did this thing with the yoga ball. Ah, yes, I know the yoga ball. That's the story.
You know, up till then, it was really just a, let's prove that this is possible. But then the public reaction this triggered, both from the broader public as well as from a lot of aviation experts, they came back to us and said, guys, this is fantastic. We've been theorizing about distributed electric propulsion for decades, and here you go actually proving the point, because this opens up a whole new paradigm for safety in aviation.
Spurred on by the enormous interest, they secured funding and began seriously developing the concept.
I thought that it's so obvious, many people in this world would be working on it. Later on, it turned out for years there were no followers. I mean, we were the only ones.
Young companies are like young people. They create these wonders because they're too busy doing something else when they're being told that it's impossible.
Now, when we started out, there were so many people telling us, guys, do you know all the problems that you're facing, right? And we said, luckily we don't. You know, so now looking back, many people are like, okay, it took outsiders to take on this view, because an aviation insider would have never set out on that journey. All he would have seen were challenges and problems that seemed, you know, unsurmountable to him at that time. We try to maintain that original spirit for as long as possible, because it's made possible what was viewed as not being possible at the time.
It was not the original idea to be a pioneer, but then it turned out we are.
A team of 10 became hundreds. Satisfying the rigorous demands of certification meant that every part of the system was redesigned, made safer, more reliable, able to cope if something went wrong.
We have redundancy in all of our critical components, right? Most visible in our electric propulsion unit. So we have 18 propellers, and obviously a number of those can fail and we can still safely complete our mission. And this is completely new. If you look at a traditional helicopter, there's a whole very complex change of components, mechanical components, that if one of those elements fails, the entire aircraft is in serious problems. And that's very different here with the volocopter. And this safety architecture allows us to build air vehicles that we weren't able to build in the past that are much, much safer than what we know today.
This, combined with the much lower noise levels, means that objections that are previously applied to helicopters operating in cities could potentially be addressed. Which is why this flight in Singapore was so important. Having secured permission to fly here, Volocopter hoped that it would be a glimpse into the future. Duncan Walker from British company Skyports was responsible for creating what can best be described as a temporary pop-up airport, known as a vertiport.
Yeah, hundreds of people in the vertiport all waiting, and it was torrential. Absolutely, you know, like Singapore, it just poured with rain, poured and poured and poured.
Not so happy about the weather. A little bit nervous that the whole event would not happen.
It's military airspace, so you only get a defined area. It's not like you can just kick it down the road and say, oh, we'll do it at 2 because 1 o'clock doesn't work. You're doing it by midday or you're not doing it. So we had all these people doing, cutting the ribbons, press, the TV crews were there. And at the last minute, the skies opened up around the bay. It worked perfectly, but I don't think at the time they realized quite how close it was to not going.
It was a very special day for me, of course, yes. I mean, obviously.
And we got incredible feedback from regulators, from city officials, from administrators, but more so from the public who, for the first time, had been able to see it, sit in it, understand what it was, hear it, or more importantly, not hear it. They don't even turn around because they don't know it's there. So there's a load of really great things we could take from that and then apply them to other cities around the world.
We don't want this to be a rich man's toy, you know, very similar to helicopters are today. We want this to be a professionally operated fleet available to the public. That means the citizens and the visitors of a city. And by that, we can actually, you know, democratize the access to this new technology. And we can scale our services to a degree we have the potential to offer this at the price, you know, slightly above today's taxi ride, which really makes it accessible to broad audiences around the city.
But this is just the first part of a far more ambitious plan. Initially, these aircraft will have pilots. However, in the future, the intention is for them to be autonomous. But what exactly does that mean?
Automatic, we press the button, the aircraft flies from A to B, which is fine until there's a balloon in the way. Autonomous, the machine chooses, and we hope it chooses to fly around that balloon.
From a technology perspective, we can do it, even today.
We can, for example, automatically detect emergency landing sites along the trajectory, whether it's free and good to land. We can, you know, detect birds or elements like another aircraft or even small drones at sufficient distance in order to initiate a countermeasure in order to avoid such an obstacle and avoid any conflict that might occur. So that's technology we can already showcase today, but we continue to work on those with a host of partners, such as research institutions and commercial partners as well.
There are a number of challenges for urban air mobility. I always put them into 3 buckets. There's regulation, there's technology, and there's social acceptance. Technology you can solve. If you throw enough money and enough brains at it, you can solve the technological challenges that are being worked through at the moment. Regulation is on the right path. Timing is less easy to influence than technology, but there's momentum there, driven by business case, driven by innovation, driven by safety cases. The big unknown is social acceptance. When this is ready to go, do people adopt it as a form of transport? Do people embrace it? Do they love it because it's saving them time, solving problems? Or is it a bit more of an unknown that people are nervous about using and takes a longer time to get up the adoption curve and really scale?
But could drones offer a means of socially acceptable transition? Duncan and his team have already begun trials with drone deliveries of medical supplies to remote Scottish islands on behalf of the NHS, the British National Health Service.
It's really exciting to be flying drones for the NHS. And as COVID hit, it really accelerated what we were doing with them because it made what was a routine delivery a really critical delivery, flying COVID testing kits between west coast of Scotland and the Isle of Mull. Very challenging, certainly in remote areas, to put in new roads, bridges, tunnels. But drones can circumvent a lot of that. They can provide services to communities which are underserved with existing infrastructure, and can really change lives very dramatically in a short space of time. The future is undoubtedly autonomous. It's actually easier to do autonomy in the sky than it is on the ground because there's fewer random events, there's less balls bouncing down the road and kids crossing the road.
In recent years, there has been a proliferation of new companies entering the urban air mobility market, hoping to be part of this new autonomous revolution.
There's nearly 200 companies out there in the world at the moment, and that's not including the ones that are working in secret, and there is such a thing.
One company, EHang, based in China, has even begun making autonomous passenger flights.
So they've been able to create a very, very nurturing environment within their own borders. The problem is when they come to export into the wider world.
The regulatory regime in China is very different to the rest of Asia, to Europe, to the US. And in controlled environments, they can do things, frankly, just much more quickly than we can do in the Western world. How that translates to the Western world is a bit of an unknown.
There's going to be an issue of how do we mesh those different regulations. And it's going to become a political issue, and only time will tell to see how that plays out. So what about the future of urban air mobility? That's going to be up to us, frankly. We've got the technology, we know what we can do. The biggest issue is going to be, do we want it?
Without question, the way we fly is about to change. A change that is not being driven by the conventional aerospace industry, but by a new breed of aviators, not afraid to think differently.
As long as we continue to say, well, if the solution isn't 100% and it can't do all of my ranges and replace all of my aircraft, I'm not going to do it. That's putting your head in the sand and saying there's no problem. Instead, change the way you think and look at it piecemeal. If there's something I can solve today, let's solve it.
You have the power to actually do something yourself. With that power comes the responsibility to do something about it.
So here we had some guys who built something in their garage and showed to the world it's possible, but all the aviation industry had nothing.
It starts on this level of small, light planes, and it will grow into larger systems as we move ahead.
Technology is the only key that I see to open up a brighter future that can be sustainable at the same time.
If we can be sustainable with all of these aspects together, we really change the way we live. And I think it's about time we did that.
I wish I was starting my time in aerospace now, because it really is the most wonderful time. It's a brand new beginning.